Welcome to Lesson 5.4. Today we're going to talk solving multiplication and division equations. Our learning objectives: being able to solve single variable multiplication equations, being able to solve single variable division equations, being able to recognize and apply the multiplication and division properties of equality and the inverse relationship of multiplication and division, and being able to model and solve real-world problems using multiplication and division equations. Here's our introduction problem. Make sure you read this before moving on. So as you saw in the last lesson, we can have equations with addition and subtraction in them. We can also have equations with multiplication and division in them. These single variable equations can be solved for the value of the variable. We want to solve the equation and figure out what the variable is equal to. So how do we do that? In the algebraic equation below, the variable z represents only one possible number. Z times 2 equals 8. What number does z represent? We can find out by asking ourselves, what number, when multiplied by 2, equals 8? Since 4 times 2 equals 8, z must be equal to 4. We solve this equation using mental math. So what happens when we have a more challenging equation to solve? Some equations are more complex and mental math might not get the job done. To solve a more complex equation, such as z times 7 equals 105, we need to use a different strategy. Let's take a look at one strategy for solving that equation now. One strategy for solving an equation is to use inverse operations to isolate the variable. Remember, isolate the variable means getting the variable by itself on one side of the equal sign. To solve an equation in which the variable is multiplied by a number, we can use the inverse operation of multiplication, which is division. We can divide both sides of the equation by that number to find the value of the variable. We must divide both sides of the equation by that number because of the division property of equality, which states if a equals b and c does not equal 0, then a divided by c is equal to b divided by c. This is much simpler than it looks. If you divide one side of an equation by a non-zero number c, you must divide the other side by that same number c to keep the values on both sides equal. So we've got z times 7 equals 105. Right now we're dividing by 7, or multiplying by 7. So to undo that multiplication, we need to divide by 7. And if you divide one side by 7, you have to divide the other side by 7 too. So on the left, what's going to happen are the 7's going to cancel out, leaving just z. And on the right, 105 divided by 7 should get you 15. So our answer is z equals 15. Negative 8 times r equals 128. So right now, r is being multiplied by negative 8, even though it doesn't have that multiplication symbol when they're right next to each other like that. That's multiplication. So to get rid of that negative 8, I divide by negative 8. And if I divide the left by negative 8, I have to divide the right by negative 8 as well. The negative 8's will cancel out on the left, leaving just r. And if I do 128 divided by negative 8, I will get an answer of negative 16 if I type that into my calculator. So r is equal to negative 16. So if you remember, in a previous chapter we talked about what happens when you divide by negatives or positive numbers. Remember, a negative divided by a negative gives you a positive divided by a positive gives you a positive, and a negative divided by a positive gives you a negative. And remember this last one, these could be interchanged. So you could say a positive divided by a negative will also get you a negative answer. A few more examples here. The first one is 8a equals 64. Again, when there's no symbol in between them, that means they're being multiplied together, so that's really 8 times a. So to undo that multiplication, I'm going to divide by 8. And if I divide the left by 8, I have to divide the right by 8 as well. 8 divided by 8 goes away, leaving just a on the left. 64 divided by 8, if I type that in, I would get an answer of 8. So a is equal to 8. The one in the middle, I've got 9b equals 81. Again, that's 9 times b when they're right next to each other. So to undo that, I'm going to divide by 9 on the left. And if I do that on the left, I have to divide by 9 on the right. The 9's cancel out here, leaving just b. 81 divided by 9, if I type that in, I would get an answer of 9. So b is equal to 9. Go ahead and pause the video, solve the last one on your own, and then hit play and see how you did. So for negative 4x equals 12, you should have divided both sides by negative 4, giving you an answer of x equals negative 3. So now we're going to look at division equations. So sometimes you'll see equations that have division in them. Remember, we can use a fraction bar to show division. To solve an equation in which the variable is divided by a number, we use the inverse of division, which is multiplication. We can multiply both sides of the equation by that number to solve it. We must multiply both sides of the equation by that number because of the multiplication property of equality, which states that if A equals B, then A times C equals B times C. So if you multiply one side of an equation by a number C, you must multiply the other side of the equation by that same number C to keep the values equal. Okay, so now we've got K divided by -4 is equal to 12. So now we're doing division, so to undo division, I have to multiply. So what I'm gonna do is I'm gonna multiply by what we're dividing by. So I'm gonna multiply that by a -4. If I do that on the left, I have to do that on the right as well. And what's gonna happen is this -4 is gonna cancel out with this -4, leaving just K on the left. And on the right, if I type 12 times -4 into my calculator, I will get a -48. So my answer is K is equal to -48. This problem, I've got n divided by 1.5 is equal to 10. Remember, a fraction is the same as division, so to get rid of this 1.5 on the bottom of my fraction, I'm going to multiply by 1.5. And if I multiply the left by 1.5, I have to multiply the right by 1.5 as well. On the left, the 1.5s are going to cancel out, leaving just n. On the right, 10 times 1.5, if I type that into my calculator, I get 15. So my answer is n equals 15. A few more examples here. The first one, we got y divided by 5 is equal to 6. So to get rid of this 5, I'm going to multiply by 5. And if I multiply the left by 5, I've got to multiply the right by 5 as well. The 5s are going to cancel out, leaving just y on the left. 6 times 5 is 30. My answer is y equals 30. So the middle one, x divided by a -2 equals 5. Again, to get rid of this -2, I need to multiply by -2. And if I multiply on the left, I have to multiply on the right as well. The -2's will cancel, leaving just x. And on the right, 5 times -2, if I type that in, I would get a -10. So I get x equals -10. Pause the video, solve the last one on your own, and then hit play and see how you did. So for b divided by -4 equals -3, you should have multiplied both sides by -4. On the left, that'll cancel out with the -4 on the bottom, leaving just b. And on the right, -3 times -4 should give you a positive 12. So our answer would be b equals 12. So now we're going to take a look at real-world problems. Equations are very useful when working with real-world problems. In fact, an equation is often the best way to sift through the information in a problem. Select the correct information and solve an equation to find an answer. Let's apply what we've learned to some real-life dilemmas. 3 friends evenly split the total cost of the bill for their lunch. The amount each friend paid for his share was $4.25. So we're going to write an equation for C, the total cost in dollars of the bill for lunch. Okay, so C is the total cost, and 3 friends evenly split it. So we're going to take that total cost and we're going to divide it by 3. And then that's going to be equal to what each friend paid, which is $4.25. So my equation is C divided by 3 is equal to 4.25. For the second part, to determine the total cost of the bill, well, right now C is being divided by 3, so to undo that division, I need to multiply by 3. And if I multiply the left by 3, I have to multiply the right by 3 as well. On the left, the 3's cancel out, leaving just C. On the right, 4.25 times 3, if we type that into our calculators, we should get the answer is 12.75. So the total bill was $12.75. So our next problem, we've got this lady that earns $8 for each hour that she works, and she earned a total of $168 last week. So we're going to write an equation to represent H, the number of hours she worked last week. Okay, so she earns $8 for each hour. So we're going to take 8 times the number of hours that she worked, which we're going to represent with H, and that's going to be equal to her total that she earned, which was 168. So our equation is 8 times H equals 168. So now we're going to solve for how many hours that she worked. So to do that, right now it's being multiplied by 8. So to undo that, I need to divide by 8. And if you divide the left by 8, you have to divide the right by 8 as well. The 8's cancel on the left, leaving just the number of hours that she worked. And on the right, 168 divided by 8, if we type that into our calculator, we get that she worked 21 hours last week. Here's the ending to the original problem. Make sure you read through that before moving on. So just some review. Always check your answer by substituting the value back into the original equation. The division property of equality states that if both sides of an equation are divided by the same number, they will stay equal. And the multiplication property of equality states that if both sides of an equation are multiplied by the same number, they will stay equal.